see. I hope everyone is aware of this thing. Now, see, these are the characteristic of low pass filter, high pass filter. Is it okay? Is this okay? Yes. Now, what is seen here? What is observed here? Yes, we'll see that this is the low pass filter. So the frequencies, this is the cutoff frequency, right? So now frequencies below cutoff are passed, while frequencies above cutoff are stopped. This is pass band, this is a stop band. And if the characteristic is like this is omega c, right? Right? So now it is the ideal response. It is a flat, 100% flat in the pass band, right? And you have the line with infinite slope. But practically it is not possible, right? That the reason we have seen, because if you calculate h of n or h of p, it is of infinite length and non-causal. That's why you cannot realize this. So what is done, instead of infinite slope, you can have like this slope, right? So now what is given in this case? This is the practical response. And how do we define cutoff frequency? Cutoff frequency omega c or fc is the frequency at which, if the gain is 1 here, so it will be 1 by root 2. Do you know, yes, about the filters? Pranav, do you know about these filters?
Yes, ma'am, we did.
Okay. So shall I go ahead? No need to explain. What is the 3 dB? If you convert
Ma'am, the
this filter,
image is a bit blurry.
okay,
People
okay.
can.
No issues, no issues. See, this is only the response I have shown. Next, see here. Is it okay now? Is it okay?
Yes, ma'am. Yes, ma'am.
So now, see here. What is not, ideally, it is not possible. That's why this is the magnitude characteristic of realizable or practical low pass filter. Now, see here, what is done, what is the magnitude is on this axis, HA of j omega. A means analog filter. We are focusing on analog filter. We know that if Hs is given, how to convert it to H of Z by using impulse invariant transformation and bilinear transformation. Now today we are looking for how to determine H of S if it is not given. That is also part of, it is understood that actually you have done in earlier semester, but let me revise, right? So now HA of j omega is magnitude response. It is a function of omega, which is capital Omega means it is the analog frequency. A means analog, right? So this is the practical frequency response. Now what do you observe? Here it is not 100% flat. Ideally we need flat, but it is not there. Then also it is called as maximally flat filter. This is called as a ripple, which is tolerable in the pass band. Then see, ideally cutoff frequency is there, so there should be sharp cutoff, right? But practically we know that infinite slope line is not possible, so we are providing a slope to this line, and you have, yes, omega p and omega s. Omega p means pass band edge frequency, where ripple is acceptable, right? And from this, it is coming down like this, and then it is, even though we are expecting 0 in the stop band, but practically it is not possible. So this much is tolerable, right? So this is called as a stop band ripple. This is the tolerance in the pass band, tolerance in the stop band in case of magnitude, right? Is it okay? Now, how much tolerance you are providing, where you call this as a pass band edge frequency, and this is a stop band edge frequency. The tolerance is accepted. So now, and this is a delta S, right? Now, where will be the cutoff frequency omega C? Who will answer? Omega C will lie where? Yes, it will be here or here or here. Tell me, how do you expect? Suppose omega C is the cutoff frequency. Where it should lie? Yes, Kajal? Kajal Jadhav? Devashri Das? See, omega C, the cutoff frequency, it should be in between omega P to omega S, right? And this is called as a pass band, where the